Good afternoon, everyone, and welcome to the IMath Webinar series. I am Gino Angelo Velasco of the Institute of Mathematics. So first of all, I would like to remind everyone that this webinar is being recorded and it is being streamed live on YouTube, and the link is posted or will be posted on our official Facebook page. Okay, so I think you are all on mute by default. And yeah, if you wish to unmute yourselves, kindly raise your hand. Okay, so today we'll be hearing from the matrix analysis and linear algebra group of the Institute. Okay, so we would like to welcome Mr. Mark Lexter De Lara. He is an instructor of the Institute of Mathematics, and he is currently completing his PhD. His research interest is on matrix analysis and matrix decomposition. So today he will be talking about his work titled On the Per-Unitary Diagonalizability of Per-Hermitian Matrices. Okay, so let us all welcome Mr. Mark Lexter De Lara. Let us give him a round of virtual applause. Okay, Mark? Okay, so I think he is connecting. Yes. So both of your accounts are on our co-host now. Okay, so
thank you po, sir. Thank you very much for the very wonderful introduction. So before my face reveal, mag-share screen po muna ako. Okay. I'm using two accounts kasi yung isa po pang slides, and then the other one is for the face cam. So good afternoon to our televiewers. Yes. Pinaghandaan ko po talaga tong araw na ito. Matagal pong hindi nakapagpagupit, kaya po ganito ang itsura ko. Marami po nag-request na mag-wig daw po ako, pero mainit po, kaya tatanggalin ko po. Okay. Char, dalawang pong wig yan. Okay, so on the per-unitary diagonalizability of per-Hermitian matrices. Okay, so before anything else, I would like to introduce some notations and definitions so that we have something to talk about, of course. Pero maikli lang po, mga 2 slides lang po. I think familiar na po yung iba dito. So the first one, the set of n by n complex matrices, we use this notation. So that is number 1. And then number 2, we use this notation for the set of n by 1 complex matrices. So these are column vectors whose entries are complex numbers. And ito siguro si number 3 yung medyo bago. We have R sub n to be the n by n backward identity matrix. So we call it the backward identity matrix simply because mukha siyang identity na binaliktad. So the identity matrix looks like this, right? Ay, baliktad pala. Pag ganyan po ang identity. And then the rest is 0. That's why we call it the n by n backward identities. So I mentioned this R sub n because we're going to use this all throughout the talk. And some definitions, we only have 3 for this talk. So number 1, we have a per-Hermitian matrix. So a matrix A is said to be per-Hermitian if it satisfies this condition. So Rn A star, Rn inverse is equal to A. Mamaya magdedwell tayo kung bakit ganyan yung pangalan nila. Number 2, a non-singular matrix U is said to be per-unitary if Rn U star, Rn inverse is equal to U inverse. And number 3, a matrix A is said to be per unitary diagonalizable if U inverse AU is diagonal for some per unitary matrix U. Okay, so chika-chika po muna tayo. Char. So ang goal po natin for this talk is to investigate the eigenvalues and eigenspaces of a per-Hermitian matrix to come up with necessary and sufficient conditions for per-unitary diagonalizability of per-Hermitian matrices. Okay? And ito po yung thesis problem ko in 2018. So this is tawag dito. Dito po nang galing ang aking talk. So, the one that I'm going to present today is a part of my thesis in 2018. So, yung ginawa ko po, this is the problem. So, give necessary and sufficient conditions for per unitary diagonalizability of matrices in MNC. So, n by n complex matrices. So, yung for today, per unitary matrix lang po pag-uusapan natin because important po yun for for this result. Wala na spoil. Okay. So, for this result. At saka medyo mahaba po kasi siya. So, kaya namili na lang po ako. And this talk is tailored fit for you. May pag-ganon. Ito, share ko lang po yung picture namin in December 14, 2018. So, this is after my thesis defense. So, hindi pa ata ito nakikita ng ibang tao, especially Ma'am P, Ma'am Paras, yung picture namin. So, from left to right, so we have Miss Dayan Telejo, one of my thesis examiners. Actually, lagi akong kinakabahan pag nagtatanong siya. Kapag explain why. So, feeling ko naman na-satisfy siya sa mga sagot ko. And we have Ma'am Paras, si naka-violet. So, siya po ang aking thesis leader. Hi, Ma'am. Kung gusto nyo mag-take ng 214, take na po kayo ng Math 214 under Ma'am Paras, matrix analysis. Malaking tulong lalo na po sa mga nag-linear na or matrix analysis na research. O libreng plug na po yan. So, take Math 1214. Tapos ako po, ayan, hindi po ako naiiyak, natatawa lang po ako dyan. Kasi tawan-tawa po ako dun sa nagpipicture. So si Raymart po yung nagpipicture, my journalism team. So, so I have my journalism team with me during my thesis defense. And then we have Ma'am Betty. Ayan po, nakaganon po sila. Hindi ko po alam anong tawag. Puso po ata yun. And of course, ang aking nanay, na si Sir Ralph John de la Cruz. Wow. Okay, so sino po tayo? So going back, let us compare yung definitions that we have with the usual definitions na meron tayo. No? So we know that a Hermitian matrix A, A is equal to A star, which you can also write as the identity A star plus identity inverse or the identity. While if you have a per Hermitian matrix A, sabi natin, ito yung definition niya. Okay, so parang ang ginawa lang natin, we just replace the identity by the backward identity. And the same goes with unitary matrix U. U is non-singular. U inverse is U star, or identity U star, identity inverse. And we have the per unitary U. U is non-singular. U inverse is this one. Pinalitan natin si identity by the n by n backward identity matrix. And in our usual setting, we say that A is unitary diagonalizable if U inverse AU is diagonal for some unitary U. And in our talk today, we have per unitary diagonalizable matrix A. And that is the case when U inverse AU is diagonal for some per unitary U. So nakikita niyo yung parang parang the same lang sila. Okay, so meron lang tayong sariling version ng Hermitian, unitary diagonalizable. And dun sa mga other works, actually, they also have their own version of Hermitian, unitary diagonalizability. And nagbigay sila ng tawag dito, necessary and sufficient condition for their own version of unitary diagonalizability. And what's so cute about this identity and the backward identity is that when you square them, you get the identity. That's why we have this and this. Okay, so parang nung una naisip ko, siguro parang pareha lang yung magiging result in the end, no? Because for unitary diagonalizability, we have necessary and sufficient condition. So sikat na sikat ito, especially sa 211. We call this the spectral theorem for normal matrices. So isa-state ko lang ngayon. So let's say we have an n by n complex matrix A. So the following are equivalent. The matrix A is unitary diagonalizable. That is, U inverse AU is diagonal for some unitary U. So that is equivalent to the matrix is normal, meaning A and A star commute, or AA star is equal to A star A. So that's what meaning by normal. And we have this eigenvalue criterion. So if lambda 1, lambda 2, up to lambda n are your eigenvalues, if this thing happens, yung trace ni AA star is equal to sum of the modulus square of the eigenvalues, then your matrix is normal or unitary diagonalizable. Or pwede ring trace ni A star A. And last, there exists an orthonormal set of n eigenvectors of A. And this n eigenvectors, pwede mo actually ipunin yon, form them into a matrix. So this n eigenvectors will serve as the columns of a matrix. And you can pick that matrix to be U. That is unitary. And when you form this, you get a diagonal. Okay? So, because of this spectral theorem, etong mga examples na to are normal matrices. Actually, when I was taking 211, hindi ko maalala tong mga bagay na to no, before the exam. So, pag sinabing Hermitian, normal siya. Skew Hermitian, normal. Unitary, normal siya. So, buti na lang meron akong seatmate that time. So, si Teddy, sabi niya sa akin, lahat ng sinabi ni ma'am na may pangalan, normal. So, lahat lang naman ng natatandaan kong may pangalan ng matrix yung sinabi ni ma'am at that time. So, ayun, naalala ko sila. So, basta may pangalan, normal. Although may mga ibang matrix na may pangalan na hindi normal. Basta itong tatlong to, normal ito. Therefore, unitary diagonalizable. So, which means Hermitian matrices are unitary diagonalizable. Okay, so because of that, I think it is natural to ask now, are per Hermitian matrices per unitary diagonalizable? Lahat na tayo, meron na tayong mga per dito. So per Hermitian, per unitary diagonalizable ba? So ano po ang hula natin? So magtawag po tayo from the audience. Ano pong hula niyo, Jake? Char. Ano pala ito? Recitation class. Biro lang po. So the answer for this question is of course no. Kasi kung yes, tapos na po yung talk, no? Kung permission matrices are per unitary diagonalizable. Okay, so bilang no ang answer, we must give an example of a per Hermitian matrix which is not per unitary diagonalizable. You can actually take this matrix, which is J20, Jordan block. Ano ba itsura ng J20? Sulat natin ha. Ganyan po ang J20. Direct sum with this one. And when you form the matrix, you get that. Sinulat ko na lang po. And we can check that this matrix is per Hermitian. Ang claim na lang natin ngayon that this matrix is not a per unitary diagonalizable. That is not per unitary diagonalizable because that matrix A is similar to this Jordan matrix. And it is not a diagonal. Kung diagonalizable siya, dapat similar siya to a diagonal. So yung mga Jordan blocks niya, ang size na 1 lang. So meaning, A is not per unitary diagonalizable. Kasi if your matrix is per unitary diagonalizable, it must be diagonalizable. Okay, so hindi enough na per Hermitian lang para maging per unitary diagonalizable. So kaya sabi ko, baka naman if we add the condition na diagonalizable ang isang per Hermitian matrix, maging per unitary diagonalizable na rin siya. Okay. Like side talk. Meron pa pala tayong facts. Sorry. Bago tayo mag-proceed with that. So, ito yung natutunan natin in this example. If A is per Hermitian, it does not follow that A is diagonalizable. So, kaya ko dinagdag na baka kailangan diagonalizable din siya. Per Hermitian plus diagonalizable, does it imply na per unitary diagonalizable yung matrix? Ano kaya tingin na sagot natin? Of course, ang sagot po dyan ay no. Mahilig po tayo sa sagot na no. So, ganun ulit. We give an example. We can actually take this matrix, the 2 by 2 backward identity matrix, and you can check that the eigenvalues of this matrix are -1 and 1. So, the size is 2, and you have two distinct eigenvalues. So it says something about its diagonalizability. So we can check that that matrix is per Hermitian. Gusto niyo ba i-check na per Hermitian siya? Ano ba ibig sabihin ng per Hermitian? Sige na nga, i-check na nga natin. Ano yun? Kailangan ang R2A star, R2 we get A, diba? But A is R2, so when you get its star, it is still R2. But this is the identity. So this is R2, which is A. So per Hermitian siya, walang question doon. And the next one, the matrix is diagonalizable. Why is it diagonalizable? Because you have distinct eigenvalues. So if the eigenvalues are distinct, so two distinct eigenvalues of size 2 yung matrix natin, therefore it is diagonalizable. Okay, but not the other way around. Hindi porke diagonalizable, distinct ang eigenvalues. Okay, so ano ba yan? So A is not per unitary diagonalizable. So ito hindi masyadong obvious. That's so ipapakita natin siya for this example. Okay, so kinopya ko lang ulit yung matrix natin and its eigenvalues. Suppose A is per unitary diagonalizable. So we're going to prove this by contradiction. And what do we mean by per unitary diagonalizable? A is equal to U times diagonal U inverse for some per unitary U. And what do I mean by U1 and U2 here? Sinulat ko lang yung columns ni U. Okay? And then, the column corresponding to 1, to this eigenvalue, is column 1 of U. That's why the eigenspace corresponding to 1 is the span of U1. And then next, so U is per unitary. We have this thing. So paano nakuha yan? We mean by per unitary is R U star R is equal to U inverse. Hindi ko na lang sinulat yung subscript para less yung sinusulat ko. So what we can do is, nag-alarm. Okay, so what we can do is you can actually multiply sa right ng U. Get the identity. Tapos mag-multiply ka sa left ng R. Maging R U star R equal to R. But R is the identity. That's why we have this equality. Okay? So, and next, paano nakuha ito? We will try to compare the 1-1 entries. U star R2U, ito nakabilog natin. So, ganito itsura niyan. So, let us get U star. U star is U1 star. So, magiging ano na yun, no? Rows na siya kasi in-star mo siya coming from here. Okay, columns yung U1 and U2. Then we have R2, tapos U1, U2. And if you want the 1-1 entry, so row 1, U1 star, R2, and then column 1. But R2 is a 2 by 2 backward identity matrix. So it's 1-1 entry is 0. Kaya meron tayo nito. Okay po ba yun? So feeling ko nagkaintindihan na tayo sa part na yan. Okay, so let's proceed. So let V be this vector which is non-zero. So this vector V is in the eigenspace. Bakit siya nasa eigenspace ni A? Kasi if you compute AV, madali bang makita to? Feeling ko naman. 1, 1. You still get 1, 1, which is 1 times V, no? So eigenvector si V corresponding to 1. So therefore, it's in the eigenspace corresponding to 1. So clear po ba yan? And then next, masasabi natin that U1 is a scalar multiple of V because this eigenspace is equal to the span of U1. And K must be non-zero kasi this U1 and V are non-zero. U1 cannot be the zero vector kasi column siya ng isang per unitary matrix which is non-singular. Okay, next. Okay, so compute lang po tayo ulit. So if we try to compute this thing, kailangan ko ng space. This thing, so let us plug in U1. U1 is KV. That's why we have this. And then anong mangyayari if you get the star, you get K bar V star R2 KV. Tapos itong K na to pwede mong ilabas. That's why you have this a modulus square ni K times this matrix or times that scalar. And that scalar is, what is V star? Maging ganyan siya. And then si R2, and then 1, 1. Which is, pag minultiply yung matrix na yun, that is 1 plus 1 or 2. Okay, that's why we have this thing. Pero sabi natin that K is a non-zero complex number. So meaning its modulus square is non-zero times 2 non-zero, which is non-zero. So which is a contradiction. Saan siya nagko-contradict? Ayan. Okay. Kino-contradict niya yung part na yon. Okay, so therefore A is not per unitary diagonalizable. Diba interesting siya? Per Hermitian, ginawa mong diagonalizable. Hindi pa rin siya per unitary diagonalizable. Hindi katulad sa usual case natin when you have a Hermitian matrix, unitary diagonalizable na agad siya. So ito yung mga natutunan natin from that example. A per Hermitian matrix which is diagonalizable, A, so kunyari A satisfies that. It does not follow that A is per unitary diagonalizable. If it is per Hermitian and diagonalizable. Okay, so hindi enough A yun. And additional fact, so if the size of your matrix is 2 or above, so this backward n by n backward identity matrix is per Hermitian diagonalizable but not per unitary diagonalizable. So if you want the proof po, check. Pwede ko po ibigay sa inyo yung copy ng aking manuscript for that part. Okay? Excuse me. So kaya ang ginawa na lang namin, so kumuha na lang muna kami ng necessary conditions pa. And we tried na baka these necessary conditions, makuha natin yung pabalik, which is the per unitary diagonalizability. So let's say A is per Hermitian, okay? Per Hermitian muna tayo ha. Wala pang diagonalizable or something. Per Hermitian lang muna. So A and A bar are similar. So why are they similar? Because if A is per Hermitian, A is Rn A star, Rn inverse, which means that A is similar to A star. So yung wiggle po na ganun, so that stands for similar. But A star is A bar transpose, right? But A bar transpose is similar to A bar. So since similarity is an equivalence relation, A and A bar are similar. And next, let us write A in its JCF. So kunyari, this is its JCF. No. Okay, so pwede namang permute yung blocks, pero later na yan. So if you want to get a bar, magbabar lang tayo dito. That's why we have this. Pero anong sabi natin from the first bullet, A and A bar are similar. So if you have similar matrices, they have the same JCF up to permutation ng blocks. So pwedeng maggulo-gulo lang yung blocks nila, pero pareha lang yung mga blocks talaga. So ibig sabihin, these blocks, etong JCF na pareha lang yan, naggulo-gulo lang siguro yan in the process ng pagbabar natin, okay? So, may masasabi na tayo about this, no? So let's say lambda is non-real. Kung non-real ka, let's say this is non-real. So doon sa JCF mo, meron kang lambda bar. Right? Which is also non-real, na not equal to lambda. Kasi lambda is non-real. And yung size ng blocks nila, magkapareha. So it means if you have a non-real eigenvalue lambda of a per-Hermitian matrix, it must follow that lambda bar is also an eigenvalue of your per-Hermitian matrix. And since magkakapareha yung size ng blocks nung lambda tsaka lambda bar, so they must have the same algebraic multiplicity. So may napala naman tayo for a per-Hermitian matrix sa kanyang non-real eigenvalue. Doon sa real eigenvalue, wala akong masabi kapag per-Hermitian matrix lang. Kaya kumuha ako ng necessary condition for per-unitary diagonalizability of a per-Hermitian matrix. So let's say you have a per-Hermitian matrix which is per-unitary diagonalizable. What can be said about its eigenvalues, the real eigenvalues? Kasi kapag per-Hermitian ka, may masasabi na tayo sa non-real eigenvalues niya. Okay? So suppose A is equal to UDU inverse for some diagonal D and per unitary U. So that's what we mean by a per unitary diagonalizable matrix. Ang claim natin dito, susulat ko yung claim natin. Ang claim, B is per Hermitian. Okay, para alam natin kung saan tayo pupunta. Per Herm na lang. Okay, is per Hermitian. So we actually have this equality. Isa-isahin natin so that madali siyang mag-get. So this one, this is because A is per Hermitian. Okay? And then, yung kasunod, A is UDU inverse. So paano nakuha itong thing na yan? So let's do this by hand. We have RNs, pamigay natin yan, no? So we have U, anong tawag dyan? Negative star. Ibig sabihin ng inverse and then you get the conjugate transpose. Okay? Tapos, maglalagay ako ng dalawang Rn. Dalawang Rn is the identity. Oops. Hala, ayaw na sumulat na walang tinta. Nagbablot yung ballpen. Okay, so since U is per unitary, etong part na to magiging U inverse. Tapos Rn, D star, Rn. Tapos this part is U inverse. That's why we have this result. And then, A is UDU inverse. That's why we have this. Oops. A is UDU inverse, which is this one. So, inequate lang natin sila. And U is non-singular. pwede mo nang i-evict yung mga U tsaka U inverse. That's why D is equal to this one. So we have shown that D is per Hermitian. So if A is UD U inverse, where A is per Hermitian and U is per unitary, then yung diagonal mo must be per Hermitian also. Okay, so may masasabi na tayo dito about the real eigenvalues. So, nire-write ko lang ulit yung naka-red. So if we let D to be the diagonal whose entries are D1, D2, up to Dn, D is per Hermitian implies, so magsulat-sulat muna tayo. Okay, so D is per Hermitian, we have D is equal to Rn, D star Rn, which is D1. Okay, what happens if you apply star to a diagonal matrix? Magkakaroon lang siya ng bar dyan. So, alisin na natin ito. Okay, let us perform this multiplication. So, Rn is the n by n backward identity matrix. So, pag in-apply mo yan sa right nung diagonal natin, mapapermute yung columns nung diagonal from left to right or right to left. That's why we have this one. And if you apply the backward identity matrix dun sa left ng diagonal, magpa-permute yung rows nung diagonal from top to bottom or bottom to top. Kung ano po ang gusto ninyo. Sa top to bottom or bottom to top. Okay? Nasa ano lang po yung point of view. And this is our D. So yung D mo, parang meron siyang special structure. And what is that special structure? If D1 yung nasa 1-1 entry mo, so itong nasa dulo, must be D1 bar. Tapos ito, D2, yung nandito, D2 bar. Etc. Hanggang umabot ka sa gitna kung size nung D mo is odd. Pero kung even, wala kang odd. Okay? So, ano ba yan? Naghaharutan yung mga pusa. Okay, that's why. Ganyan ang itsura ni D. And remember, if you have a diagonalization of a matrix, so this is a diagonalization of A. So yung diagonal entries mo are the eigenvalues of your matrix, right? So it means, kuwari, kung ito yung lambda, which is real, dito sa dulo, lambda bar is also lambda. So sinasabi niya na parang yung mga real eigenvalues mo, nakakam sila in pairs, right? So, masasabi natin from here that if A is per Hermitian and per unitary diagonalizable, then the real eigenvalues of A has an even algebraic multiplicity, except for exactly one real eigenvalue when n is odd. Because when n is odd, meron kang something dito na real. Okay. So pwedeng siya lang mag-isa or pwedeng may mga kapatid pa siya dito na real eigenvalues when n is odd. Pero sure tayo na isa lang yung magkakaroon ng ganong case. Okay. So ito na ulit. So a moment of truth. Question number 3. So dadagdag natin yun sa mga conditions natin. Okay? So we have a per Hermitian matrix A, which is diagonalizable and satisfies this condition. So even lahat ng algebraic multiplicity of every real eigenvalue except for exactly one real eigenvalue when it is odd. So does it follow that A is per unitary diagonalizable? What do you think? Magtawag tayo sa audience. Ano po ito? Yes or no question lang ito. Herald, ano sa tingin mo? What do you think is the answer? Yes or no lang? Char. Okay. Sagutin na nga natin. So the answer for this question is tada, no. Ay, hindi pala pwede mag-unmute. Okay, so no pa rin ang answer dyan. So dahil nga no ang answer, dapat tayong magbigay ng, ang sagot daw ni Harold is no. Uy, nauna ako mag-show ng answer ko. Char. Okay. So we can actually take this matrix, the 3 by 3 backward identity matrix. Its eigenvalues are 1, 1, and -1. So A is per Hermitian, diagonalizable. We can check that this matrix is there. Hindi siguro obvious na diagonalizable siya, no? So let us establish that A is diagonalizable. And what happens if you square A? You get the identity. So A satisfies x squared minus 1 equal to 0. So pag pinlog in mo dyan si A, you get 0, right? So ibig sabihin, yung minimal polynomial ni A must divide x squared minus 1. So you have 3 possibilities. So x squared minus 1, x minus 1, x plus 1. So if these two are your minimal polynomials for, ayan, nagme-message na yung mga tinawag ko kanina, nagagalit na sa akin. Okay. So, ang mangyayari dito, yung A mo magiging plus minus the identity if either one of that is your minimal polynomial. So we have no choice na maging ito yung minimal polynomial natin. So ang minimal polynomial ni A is x squared minus 1, which is x minus 1. X plus 1 siya, a product of distinct linear factors. Diba sabi natin sa linear algebra, kapag ang minimal polynomial ng matrix mo is a product of distinct linear factors, diagonalizable yung matrix mo. Okay, that's why this matrix A is diagonalizable. Okay. So as you can see, the size is 3, algebraic multiplicity ni 1 is 2. Even algebraic multiplicity, except for one real eigenvalue, which is -1. Its algebraic multiplicity is odd, which is 1. But that matrix is not per unitary diagonalizable. So ang sad naman ng storyang ito. Okay. So baka siguro kulang pa ang pagkuha natin ng necessary condition. So baka we have to dig deeper. Nasa eigenvalues pa lang tayo, wala pa tayo doon sa eigenspace niya. Okay, so kuha pa tayo ng necessary conditions. So we know that this assumption, per Hermitian, per unitary diagonalizable, implies that D is also per Hermitian, right? So we write U in terms of its column. So U1, U2, UN are its columns. Okay? So U is per unitary. Pinakita natin ito kanina. U star Rn, U is equal to Rn. Ay, na-spoil. Okay, so ang gusto kong ma-observe natin dito are, what can we say about the eigenspace of a real eigenvalue? Para madali nating makita, no, let's say, our D looks like this. We have lambda here, lambda, tapos you have something, something, something. Para lang madaling makita. And then, you have U. Okay, so yun yung meaning nun, no? Okay, so, from here, so U star, ano mangyayari doon? So let's say U1, U2, and then yung last two. Magbablot talaga yung ballpen. So U1, U2, UN minus 1, UN is equal to that thing. So pag ito yung kinuha mo lang, itong part na to, when you multiply sa gitna ng R, ang makukuha mo, itong mga gilid. Yung makukuha mo, which will give you a backward identity matrix which is smaller. Mas maliit lang yung size na, pero n by n a smaller backward identity matrix pa rin siya. Okay? Yun lang yung gusto kong sabihin dito. So, if itong UR1 up to URK are the ordered columns of U corresponding to your real eigenvalue A, if you form this matrix, then V star R and V is the backward identity matrix, a smaller size. R sub K, where K is the algebraic multiplicity of lambda. And moreover, itong V star R and V, this matrix that we form from the columns of Q corresponding to lambda has, how do you read this one? Ceiling of K over 2 positive eigenvalues and floor of K over 2 negative eigenvalues. So you can get rid of that floor and ceiling if K is even. So nilagyan lang yung floor tsaka ceiling for the eigenvalue, for the lone real eigenvalue with an odd algebraic multiplicity. So ang tanong, pag dinagdag natin tong condition na to, sapat na kaya for per unitary diagonalizability? And thank God, the answer is yes. Okay, that's why we have this result. So the per unitary diagonalizability of per Hermitian matrix. So let's say A is per Hermitian and diagonalizable. Then A is per unitary diagonalizable if and only if every real eigenvalue of A has an even algebraic multiplicity except for exactly one real eigenvalue when n is odd and yung ano natin, eigenspace criterion. So suppose lambda is real eigenvalue of A and this is a basis for the eigenspace corresponding to lambda. So dun sa necessary conditions natin, kinuha natin yung columns corresponding to lambda. So yung columns na yon, nagsiserve yun as basis sa eigenspace ni lambda. Okay. Form this n by k matrix. Itong V1 up to Vk, pagsasamahin mo lang sila. And this is a n by k ba yan? Okay, tama, n by k. And this matrix is Hermitian. So, ang eigenvalues na ay real. So, it makes sense to talk about its positive eigenvalues, negative eigenvalues. Okay? So, if this Hermitian matrix has this number of positive eigenvalues and negative eigenvalues, tapos ang usapan, per unitary diagonalizable yung matrix natin. Okay? And anong ginawa namin to, the proof, baka lang kasi may magtanong, the proof is by construction. So basically, yung proof namin, it tells you how to actually construct yung unitary matrix mo para masulat mo si A as UDU inverse where U is per unitary and D is diagonal. So ganun din sa general case, kahit hindi per Hermitian yung matrix mo, mabubuo mo pa rin yung per unitary matrix mo. Although medyo mahaba yung proseso kasi ang daming ginagawa. Pero at least you can do it by hand if you have the time. So, syempre, gagawa tayo ng example, ang favorite part natin, magbigay na example. So, let us determine whether the per Hermitian matrix is per unitary diagonalizable. So, mukha siyang backward identity no, na may 2 tsaka negative 2 lang yung entries. At binigay niya na rin yung diagonalization niya where P is this non-singular matrix. Yung columns corresponding to 2, check muna natin yung algebraic multiplicities of the eigenvalues. The algebraic multiplicity of 2, asan may eigenvalues? And dito dapat tayo titingin, no? Andyan yung eigenvalues. So the algebraic multiplicity of 2 is 2. The algebraic multiplicity of negative 2 is also 2. Okay, so yung basis for the eigenvalue 2, you can pick that. And for negative 2, ibahin natin color. Ayan. Okay? So, i-check na lang natin kung nasa-satisfy ba nun yung eigenspace criterion natin. So, for the eigenvalue 2, form daw yung matrix na to, diba? This is our V. Yung mga columns corresponding to 2. Form that matrix. So, dapat, algebraic multiplicity niya 2. So, dapat isang positive eigenvalue at isang negative eigenvalue etong Hermitian matrix na yan. At lumabas naman. One positive eigenvalue, one negative eigenvalue. And the same goes with the eigenvalue negative 2. Ganun din yung lalabas. Algebraic multiplicity 2, form this matrix. So dito, obvious naman diagonal kasi lumabas. So isa lang yung may negative eigenvalue. We have one positive eigenvalue. So ang conclusion natin, the matrix A, nasa-satisfy niya lahat ng kondisyon na gusto natin in the theorem. So it is diagonalizable, it is per Hermitian, real eigenvalues of even multiplicity, and satisfy the eigenspace criterion in our theorem. So therefore, A is per unitary diagonalizable. And that ends my talk for today. I hope you like it.
Yes, thank you very much, Lexter. Thank you. So let's give Lexter a round of virtual applause. Okay, so the floor is now open for questions. Any question from the audience, you can raise your hand. And you can actually unmute yourself if you have any question. Okay, so yeah, Sir Joey says good talk. Nice weeks.
Thank you, sir.
Okay, so yeah, quick question. Meron bang relation between, sorry, baka hindi ko alam kung na-miss ko relation between Hermitian and per-Hermitian matrix?
Hindi ko po na-check. Hindi ko na-check kung meron silang relation, pero feeling ko wali. Feeling ko wali kasi ang Hermitian real, parang it does not say something about ng positive eigenvalues, negative eigenvalues. At saka ang mga per-Hermitian kasi, pwede silang magkaroon ng non-real eigenvalues, which is weird.
So baka
hindi ko
wala
lang po alam kung may relation. Hindi po namin na-check.
Okay, yes. We have a question from, may nagtaas na kami kanina sa Ma'am Beth.
Yes po.
Hi, Lexter.
Hi po, ma'am.
Salamat sa iyong napaka informative at saka entertaining talk also. I like how you also parang you took us sa journey kung paano yung nasagot yung mga tanong mo and pa isa-isang cases na-check mo yung mga hindi pwede at pwede. So actually, ang question ko lang is out of curiosity. Kasi yung Hermitian matrices, for example, may associated, meron siyang, if you talk about the corresponding linear transformations, medyo well-studied dito kasi meron tayong spectral decomposition. So I'm just wondering, meron din bang parang study on, say, the related linear transformations associated with per-Hermitian matrices?
As far as I know po, wala. Kasi parang kami lang po ata gumagawa dito. Pero pwede po namin tignan niya. Interesting.
Okay, thank you.
Okay po. Ay, may question pa. Yung per...
So sa chat, we have a question from Victor Manuel Aricheta. He asks, na-explain po ba kung bakit per ang ginamit na prefix? And Mang Kayan Arceo echoes that question.
Actually, iba-iba sila ng gamit. May collaborator. Ang tunay po kasi ng pangalan niya, hindi talaga per Hermitian, no? So, ang tunay ng pangalan is lambda Hermitian. Kasi yung transformation na lambda is, sulat nga natin. Ay, nawala. So, yung lambda po kasi, lambda r sub n, Yan po talaga yung transformation. So sa manuscript ko ang nakalagay, lambda Hermitian, tapos meron ding phi Hermitian, depende doon sa transformation na ginamit. So meron kaming collaborator, ang term niya is per Hermitian. Tapos parang hindi rin naman consistent yung gamit ng per Hermitian. So ginawa ko na lang for this talk, ginawa ko na lang per Hermitian because I don't want to mention yung mga lambda for tawag dito para mas madali po siyang maintindihan. I mean mas madaling isulat.
But
Kung
it has
bakit
already,
per.
sorry.
Yes po.
But it has already appeared in literature, yung per Hermitian.
Yung per, opo. Iba-iba rin po yung gamit. Kunwari, may nakita pa ako yung mga centrosymmetric something. Iba-iba yung meaning nila, pero same words.
Okay. I have another one. Nabanggit mo kanina, constructive yung proof nyo, no? Nung, sa diagonalizability. So, possible siyang gawa ng algorithm?
Opo, nasa manuscript ko po yun, yung algorithm po.
So, kumbaga pwede siyang ma-code na para
Pwede
mag-enter
po siyang
tayo.
ma-code.
Okay. Thank you. Do we have any other question from the participants? Okay, if there's none, let us give Lexter another round of virtual applause. Okay, thank you very much, Lexter, for taking the time
Thank you
to
po.
share your work. And thank you to the participants. Thank you to the audience for also taking the time to listen. Okay, so our next webinar will be on April 5, and it will be given by the differential equations group of the Institute. Okay, so again, thank you, and we will see you again on April 5. Okay, so enjoy the afternoon. Goodbye.
Thank you, Lexter. Thank you,
Thank you,
din.
ma'am.
Thank
Thanks,
you,
Lex.
Bye. I hope you like it.
Thank you po.
Yes naman.
Balik mo na yung wig. Balik mo na yung wig.
Meron pa kabet.
Bakit wala ka ng
Kabit.
Lexter? Ayan.
Kabit natin.
Lahat ng speakers galing sa matrix analysis dapat naka-wig next time.
Hindi sir,
Ako po
parang
ang-
kayo papatong daw po yung wig sa susunod na speaker. Sa susunod
Si
na
Mama
webinar.
Nes daw next.
Yeah.
So pinapasa yung wig na yan.
Next webinar po meron siyang passing of the wig. As the last seminar's winner.
Wala akong makeup kasi kakalipat ko lang ng wala akong makeup na dala.